Yeah, okay. So till now we have discussed the resources, that is pod, config map, service, and replica set, deployment, so secret. So we used these resources to create our Kubernetes, generally RoboShop application. We still have few more things that is very important. That is called storage. So last time we discussed why we need Kubernetes storage, because all the clusters here, the nodes, these are, we call it as worker nodes. So worker nodes are ephemeral. Okay. So worker nodes are ephemeral. So why we created Docker volumes? Because pod itself is ephemeral. Pod itself is ephemeral. Anytime it may be deleted. So if we store data inside pod, we lose it. Okay. So generally what we did in Docker, so we created Docker volumes. We created Docker volumes and mounted to container. So even the container is deleted, the data is safe inside the server. So what I'm saying here is even the servers are also ephemeral. Even the servers are temporary. Anytime they may be deleted, so they may be created again. So that is why we have to keep the storage outside. So just like we keep the storage inside our hard disk, so we will have, for example, this is the Kubernetes cluster. So there will be one EKS and we will have multiple worker nodes, okay, multiple EC2 instances. So this may be any like 2 or 3 or 4 or 10, 20 based on the project requirement. Okay. So this is the EKS cluster. So we don't want to keep the storage inside the servers also, because the servers are ephemeral. What we do, we will have some kind of storage, just like hard disk. So this is the storage. So this EKS cluster will have access to this. Okay. So now we need to little bit understand about the storage interface inside Kubernetes. That is very important, because if you are keeping some uh, data kind of applications inside Kubernetes, obviously we need to understand the storage. So here multiple types of storage are available. One is empty directory, and the another one is host path, and third one is static provisioning, and fourth one is dynamic provision. Okay. So these two are also ephemeral. Ephemeral inside pod, ephemeral inside server. So these two are permanent. Okay, external. These are external and permanent. In first two, we have some use cases. We'll discuss this. So these are also important, and then we will move to the static and dynamic provisioning. Okay. So at the time of beginning, I have discussed something called sidecars, right? So for example, if this is a Kubernetes pod, there can be two containers. One is Nginx. So this is one container, and this is another container. So what I said, the pod versus container, there is some advantage of pod versus container. So that is multi-containers in pod. And the second one is they share same storage and network, right? So here, the advantage is this may be Nginx, and this is something called sidecar. So Nginx is continuously writing some logs. So we need to persist those logs because pod is ephemeral, and we can have some elastic search. This is the elastic search. So this pod access this storage, and this one is writing this. Okay, so this is Nginx. And this is something sidecar. Okay, so this Nginx pod is continuously writing some logs, and we are keeping it inside the storage. And this sidecar is continuously accessing those logs and pushing them to the Elasticsearch. Okay, so that we can have logs outside of the pod because pod is always ephemeral. So this is the thing we discussed as part of that use case. Okay, so how to implement this? They should have, they should, sorry. So they should share the storage. So the example we can do that is empty directory. Okay, so we'll see that. And I'll ask one question. If the pod is deleted, can we get the logs of Nginx? Please answer in the chat. The pod is deleted. So do we get the Nginx logs? No. So that is why we choose ephemeral empty directory. Once the pod is alive, it will be continuously writing the logs. Then we will access the logs through sidecar. The pod itself is deleted, then you no need to access the logs. Obviously, you will not get the logs. So that is why the use case here is empty directory is also ephemeral. As long as pod is alive, so we can use this empty directory sidecar pattern to access those logs and push to the Elasticsearch. Once the pod is deleted or killed, then obviously everything is going to be deleted. But the logs will persist here still because the logs we are sending to the Elasticsearch. So that is the advantage of sending the logs to the outside of Kubernetes cluster. Okay. So for that, we need this kind of sidecar pattern with empty directory. So now I will see that example. So Nginx, something called FileBeat sidecar example. If you just type like this, maybe you'll get something. So here we have FileBeat. So this sidecar is one of the implementation of sidecar is FileBeat. So FileBeat is popular log shipping model from Kubernetes to Elasticsearch. Okay. So it needs to have some configuration. So what is that configuration? Because sidecar is shipping to Elasticsearch, it needs Elasticsearch address. Where to ship. And the second thing is it needs what are the files to ship. So we will provide this configuration through config map. We will provide this configuration through config map. So why we have config map? It is to provide the configuration. So FileBit, while configuring FileBit sidecar, FileBit configuration is very important. That is very simple also. And you'll get some examples like this. So last time we discussed, right? So this is the main container. This is the sidecar. So that is the same concept here. So you can just see the example like this. So let us create something. So in today's session, I just added something. So this is for AWS static provisioning. So what is the cluster? This one is doing is I am creating Kubernetes cluster. Okay, but I'm selecting the availability zones should be in 1A. So all the worker nodes, you can see them in 1A. Okay, you can see 1A. So there is some reason. So I'll tell you just a simple thing. Add 2 lines. I want all the worker nodes should be in US East 1A availability zone. Okay. And so let us understand storage now. I'm going to create one storage folder in K8 resources. Here the first thing is empty directory. So I'm just configuring the file bit first. So here the is no something. Yeah, this is the full example. So this is the config map. So file bit config map, and then inside this one file bit.aml. So you can see your so these are file bit related modules. And as I said, so we are giving the path for access log, var log, nginx access dot log, for error log, var log, nginx error dot log, and output. So we are accessing these two files and then we are sending it to this Elasticsearch. So this one is not available right now, but it is fine. We will discuss this later, how to ship the log files from your watch to the Elasticsearch. But at least you can see now the sidecar is going to try to send the log files to Elasticsearch. Okay, so that is what we are going to do it now. But the actual example, how to ship, really, we will discuss that later. So our intention is to write empty directory to understand empty directory. Okay. And now, so this is the deployment of engines. For example, I'm just giving nginx. App is nginx, replicas 1, and app is going to be nginx, name nginx. Everything I'm just giving as nginx. So image is nginx. And now here we need to understand how to mount. So first I'm creating the volumes here, file bit config map. This you know already. So last time we have mounted the config map through volumes. Okay, so where we did that. insert K8 Robo Shop. So we did this as part of our web container. So we created Nginx configuration as config map, and then we mounted it as volume. Okay. So the same way here, we are creating file bit config, and then we are mounting that as volume. So this is the config map, and this is the same. And you need to mount it to the file bit sidecar. So this is the file bit sidecar, and here I am mounting logs because it has to access, and then file bit config also. And this is the Nginx image. So there are two images here. You can see this containers. Under containers, we have the actual Nginx image and then file bit sidecar. So this Nginx is storing the logs inside this, and this file bit sidecar is accessing the log. So you need to mount for both containers, and for file bit extra, you have to mount for the file bit config as well. Okay, and where is the empty directory actually? So empty directory is by default Kubernetes storage. Just type Kubernetes storage, we will get this documentation. And then you can see here ephemeral volumes. Let us go to storage volumes. Now you can see empty directory. So by default, the storage here is empty directory, even you just create it or not. So I'm just giving volume is going to be empty directory. This Nginx logs is going to be empty directory. Even you don't give that, obviously Kubernetes will understand that as empty directory. It is the default volume here. Okay. So if you face this question, what is empty directory? So empty directory is a way we use it in sidecar patterns. Okay, by default, Kubernetes will create empty directory inside the pod. So that will be used to share the storage between the actual pod and then the sidecar, the actual container and sidecar container. So empty directory is a Kubernetes ephemeral volume used in sidecar patterns. Okay, so we will mount volume to main container and sidecar container. Okay, so that they can share storage. Main container will write logs. Sidecar container will access and ship logs to Elasticsearch. Okay. So first you need to create the volumes. So two volumes, and then you need to mount them. So this is the syntax. Once this is done, let us push and let us pull. Just cloning this. Kubectl apply -f empty directory. Kubectl get pods. So you can see 0 to container creating and running. So now let us get inside that kubectl exec -it -c, and then what is the sidecar name? Filebeat sidecar. Bash. Okay, so now you can just access this var log engines. So if you are accessing this through the Filebeat sidecar, then Filebeat has access to the logs. Okay, and to see that, Filebeat logs. Or just come out of this kubectl logs. Let me delete them. Kubectl delete pod. I'm just deleting so that it will create again. Kubectl logs. Let's see that. kubectl exec -it -c filebeat sidecar. Actually, if sidecar is able to access means it is working. It is able to access Nginx. So you can say that actually it is working, but the shipping we will check later. So this is just to discuss about empty directory, how to share the storage between two containers inside the pod. Okay. So this is one of the method we use it inside the containers sidecar pattern. And the second thing is host path. So now we discussed how to ship the logs of pod to the external system. And sometimes we need to ship the logs of servers, right? So we have a lot of servers running. So these are the worker nodes. So today it may be 3, and tomorrow it may be 30, and day after tomorrow it may be 40, and after a few days it may be 1 or 2. So our servers are also ephemeral. These servers are also writing continuously log files. So every server have some log here, right? Where log, and here you can see there are a lot of logs like messages, tail hyphen here, messages. This is sudo access. Your server is also writing lot of logs. So we need to get those logs also to be analyzed. So generally those logs also should be pushed to the Elasticsearch. So this one empty directory and sidecar pattern is to ship the pod logs, and host path is to ship the server logs. We use host path generally to ship server logs. So for this, generally we have something called daemon set concept. So what is daemon set? This is also a popular interview question. So if you run daemon set, Kubernetes will create a pod in each and every worker node. Okay. So if you have 10 worker nodes, then Kubernetes will create 10 pods, each pod in one worker node. So the purpose is to ship the log files. Now we can see that host path. You can see there is a warning. Host path volumes present many security risks, and it is a best practice to avoid use of the host path when possible. So host path is very dangerous to use, okay, just for storage. But there is some advantage of our host path, only one advantage, that is to ship the log files of the servers. So usually host path will have only administrator access. Host path will be only done by admins. Only one advantage, to ship server logs to Elasticsearch with daemon set. Okay. So in this case, what will happen is, so this is the server actually. So inside server, we will have one pod. So what is this pod is doing? This is the server storage. So this is the server storage. Say this is server disk. So what we do is we will give access for the pod to access this server disk, and then to ship the log files to Elasticsearch. So this pod responsibility is to only access these log files and then ship to the Elasticsearch. Okay. So here the concept is different. Here it is inside the pod. So this is the server log itself. So for that purpose, we have something called daemon set. So now we will configure daemon set. This daemon set will have something called fluent D, a shipper to access and send log files to Elasticsearch. So daemon set will access logs through host path. So generally, what is the risk? If the pod is trying to access the storage, so then it can access everything inside the server. So this pod can access each and every data inside the server disk. So that is why we will only restrict. What is the recommendation here? Specific directory. Restrict the host path to specific directory. So this is what we are going to do now. Fluent daemon set example. So here there are multiple interview questions. First interview question is, what is daemon set? So daemon set is one of the, so if you run daemon set, Kubernetes will create pod in each and every worker node. So the advantage of daemon set is generally to ship the server logs to the Elasticsearch. So this is the simple answer, and this is the best answer, daemon set. So then what is host path? Host path is a way of accessing the server storage through the pod. Host path is accessing the server storage through the pod. So in which case we use it to ship the log files of the server, we use host path. And host path is generally dangerous. It will give access to the entire server. That is why we will restrict it. So that is how we will restrict. Now we will see this. Fluent Elastic daemon set Elasticsearch example. So now let us just understand this. Host path.yaml. First thing is daemon set. So these two are different concepts here, okay? But they club to give us some use case. Earlier we discussed replica set and deployment. So daemon set is also a part of set. Fluent namespace is going to be kube system. This is admin namespace, okay? Labels, fine. This is fine. This we don't need. We'll discuss tolerations later. I'm just removing all these things for now. The difference is simple. So we'll create volumes first. And inside volumes, I'm just mentioning host path, a particular directory var log. So this is where our server is going to store all the log files. If you just see this, you can see there are a lot of logs. There are cron job logs, and there are yum logs actually, DNF or yum, whatever. So every log is going to be stored inside var.log. So that is what we are going to create the volume through the host path. You can see this host path. I created volume. Let's remove this also. And then I am mounting it to the pod. So pod will get access to this. I created volume and then I am mounting to the pod. So now only pod will get the access. Otherwise, pod will not get the access. The same way we did it in Docker as well. Okay, so any questions still here? This may be sometimes confusing, but you need to understand it multiple times through practice. Any questions? So the concept of storage is very simple if you understand it through the in a simple way. First, create volume, and then second, mount volume. That's it. Create volume is nothing but your persistence. Mount volume is nothing but giving access to pods. Yes, Janardhan?
Yeah, hi Shiva, good morning.
Yeah, hi.
See, this demand set, here we are using the kube system namespace. So it is not mandatory that we need to create a kube system namespace. It is depending on the what I say situation. Like even we can deploy this demand set in even in our customized namespace also, right? Or is it mandatory
Cube
to
system is going to be the administrator
administer?
namespace.
Correct. Yeah.
Kubectl get namespaces. So as an application, for example, you are RoboShop application DevOps engineer. So what do you care? RoboShop logs or entire server logs?
Generally, we care the entire server logs.
Why do you want entire server logs? Because it Amazon is also running inside this server, and then Flipkart is also running inside this servers, right? This
Right.
node group. So if you get entire server logs, so there is a security breach, right?
Oh, correct. Yeah.
So you are the RoboShop application DevOps engineer or developer. So you want only RoboShop logs. So those logs you are getting through this sidecar patterns,
Okay.
correct? So you are
Correct.
shipping your logs to the Elasticsearch. So this is for administrator. Sometimes the Kubernetes cluster is not running properly. Sometimes you report some problem to the Kubernetes administrator. So my application is not running, something like that, whatever it is. So admin require the entire server logs to analyze what is happening inside the worker node. Okay. So that
Correct.
is why it should be only inside kube system administrator namespace. So this is going to be purely admin activity, not the project activity.
Okay. And here we have taken the single worker node as example. So assume that we have three worker nodes. So all the three worker nodes is the concept is same, like pushing these logs to the
So that is
Elasticsearch.
the advantage of daemon set. I'm mixing two use cases. One is host path.
Okay.
Why I'm using host path? Because your pod wants to get the access of the underlying server storage, right? So this var log this var log is in the server,
Correct.
correct? So this is var log. So this is inside the server. Your pod is running, and this needs to get access to this one. So generally, this is the entire server log. If your RoboShop pod get access to this, then that is a security breach. So every server, like you assume you have 30 worker nodes. So every server is going to store the log files inside var log. Okay, I'm going to use daemon set concept, because what daemon set promise here, it will run one pod
On every worker node.
on every worker node. So daemon set ensures that nodes run a copy of a pod. Okay. So every node will run this pod. If you have 30, so then 30 pods are going to be created in each worker node. And every pod is going to access this log file and ship the log files to Elasticsearch.
Okay.
Okay. So that is the daemon set advantage. And host path, obviously we need to give access to the pod to access the log file. So we need to use host path. So
Yes.
now what I'm doing here, daemon set guarantees each pod in every worker node. One pod in every worker node. Okay. So that is done. And just running the pod in every worker node is not enough. Pod needs to get access. Gives access to the pod. Gives access to var/log from the pod. So now this pod is running and it is able to access this one, and it will ship now. Once it has access, it can ship. So how is it shipping? That is fluently. We don't need to understand. That is the fluency advantage. Okay. So now I'm pushing it full CD storage kubectl apply -f02. Now if you just see kubectl get ports in kube system namespace. As I said, this is going to be the administrator activity. Now you can see I never said 3 pods to be created. Anywhere I mentioned number of replicas 3. No. So that is the advantage of daemon set. Now if you add another worker node, automatically it will run another pod inside that. But here it is some error. Let us see the error. kubectl describe pod. Just keep on creating and then delete it. Okay. kubectl get pods. Describe pod in kube system namespace. Okay. Pulling image, successfully pulled image back of restarting file. So it is not able to start. So generally that is the image error. Just change the image. Okay. This one is not working actually, image. So there is something else. That is this one. Okay, so just like Docker Hub, we have many other things. That is something like this. And I'm giving the URL, the image, and then colon version. kubectl delete -f02. Hit pull. Now apply kubectl apply -f02 host path. kubectl get pods in kube system. Now you can see our fluentd is running. It is running in. It is running 3. If you just -o wide, this fluentd is running each and every worker node. You can see this. So this is our node IP address. It is different. So that is what the advantage of daemon set. So what is daemon set? Daemon set will make sure a pod runs on each and every node. So that is the advantage of daemon set. So why we need to run like that? Because it is one of the use case to ship the logs of server to the external system. So there we are using host path. So here 3 concepts we use this. So daemon set. Make sure a pod runs on every worker node. And another thing what we did, host path. Why we use this? To give access to server storage. give access to the server storage to the pod. Yes, that is the host part and fluentd. So this is to ship log files. Sure, keyboard is back to Elasticsearch. Okay. So daemon set will not run in master. Daemon set will only run in worker nodes. We don't need master logs. So if you add another 3 nodes, automatically daemon set will make sure another pod will run in each server node. Okay, so we used these concepts here. So that's what we said. Host path is very dangerous. We will only use it in a single use case. So that too, we will restrict it through access only log files. Now, if you give access to the pod just like this, imagine if you give access like this, for example, now pod will get the entire root file system access. If you give access to this one, that pod, so it is only accessing the log files. But if you give access to this root file system, it will have full access to everything. Okay, we don't give that. That is the host. So now we will enter into the actual storage part, static provisioning and then dynamic provisioning. First, let us see the static provisioning. So as static means, like we are attaching a hard disk to our computer. Hard disk sits next to computer. Store files in hard disk. It is very safe. Instead of storing inside the computer, we will store it, the files inside the hard disk. This is completely safe. Similarly, we discussed we will store the data in external, then it is safe. So here something EBS, Elastic Block Store. So this is just like hard disk in our AWS. You can see here, there is something called volumes, EBS, Elastic Block Store. So here you will just create volume and then you can give access. So as part of static provisioning, what we are going to do here is create one EBS volume, give access to EKS cluster. Okay, just understand this. Don't worry too much. Just understand in a conceptual way and a general way. So EKS pods will store data in EBS volumes. Okay. So now you can, now pods or servers may be deleted, but your data is not deleted. You can mount again to another pod so that pod can access the data. Okay, so this is the overall idea why we are going to use this external storage. Generally, every company will have someone called storage administrator, storage and backup administrator. So this is a separate technology. So there is something called Popular, NetApp, and some other Documentum, Dell backup, something. There are a lot of things. So their responsibility is, for example, HDFC, is doing lot of transactions every day. Ultimately, everything is going to be stored inside the disks. Okay, so the database is ultimately going to be inside the disk. You run database, you run MongoDB, you run anything. Ultimately, the data is going to be stored inside some storage. So these guys, they will make sure daily backups has to be taken and the data is always safe and the data is always available. That is these guys' responsibility. Okay. So even then HDFC may be crashed, HDFC may be down, but still the data is safe. You can run again to access the data. So that is what we are going to do here. So every company will have storage and backup administrators. So they will take care of the storage part. So here also, so we will have, so we don't know as a DevOps and cloud engineer, we don't know how to take the backup, how to keep the data safe, everything we don't know. So there is a person, so they will create and we will access. So the same way here, creating and then managing the storage is not a DevOps and cloud responsibility. It is a responsibility of storage administrator. Okay. So we no need to understand that's a separate skill. But to access the Kubernetes, so there is something called objects, that is PV. So this PV, persistent volume, persistent volume. So this is a representation of underlying storage. Okay. So now how we are going to handle is we will create EBS disk, just like hard disk. Okay. And we will create equivalent PV object to represent EBS disk. Okay. So why Kubernetes is giving this PV object is, as a DevOps or cloud engineer or Kubernetes administrator, there is no guarantee you should understand the storage technology. Okay. So that is why, so they created something called PV. You map this PV with your storage disk and then you use it. Okay. Then Kubernetes will handle in background how to access the EBS. That is, everything is the Kubernetes implementation. We don't need to understand. Kubernetes developers will understand. Okay. So we will create EBS disk. So this is simple, right? Cloud, inside cloud. Just imagine if this is not in an AWS cloud. So we need to definitely have this one, storage and backup admin, because we will not have access. Now everything is moving into the cloud. So all the roles of database administrators, storage administrators, and server administrators, all these roles are into the problem. Because earlier creating this disk outside of the Kubernetes cluster was a very big task. So this task was only done by these guys. But now everything is inside the cloud. Just with few clicks, you can create the disk inside the cloud. So that is why cloud is killing lot of jobs. Earlier it was very hard. Now it is very simple. So we will create a PV object to represent EB. Yes, disk. And there is something called persistent volume claim. What will ask for storage. Okay, we'll get full clarity within few minutes. So let me do the things first. So first thing, I'm creating one disk, like 20 GB. And just answer me something. Last time we discussed. So if the server is in your room, hard disk if you keep the hard disk in some other location, like your neighbor village, do you think it will work? Please respond in the chat. So hard disks generally they sit beside your computer or somewhere in another location. So it should be as near as possible to the server. So that is why I created the server in 1 year availability zone. Now I have to give US East 1 year. If I give US East 1B, then EBS will not work. Okay. So that is the condition. So EBS is just like a magnetic hard disk. It should be as near to the server. It should be near to the server. That is the condition. If I create EBS in 1C and if I access through the 1A server, it will not work. Okay. So that is why I'm just creating a disk in 1A region because all my servers are in 1A region. I'm just creating the volume. So this one I created just now. I'll just name it EBS static. Okay. So I created the disk. That is good. And then, so when you insert keyboard or mouse to your system, these are external devices, right? So do you know drivers, sound drivers, keyboard drivers, mouse drivers? So something external to computer, we should install drivers, correct or not? Generally, we will have sound, keyboard, mouse drivers. So every drivers will be installed, pen drivers, USB driver generally. Okay. Similarly here, I'm creating external storage. This is completely not part of Kubernetes cluster. This is completely external. So if Kubernetes cluster wants to access something external, you need to install drivers. Install EBS drivers. Okay. So now my responsibility is EKS EBS, for example. There is something called CSI driver. You don't need to understand how it is happening. I'm using keyboard. I don't understand how the drivers are installing, how the drivers are working. I just need to install them. That's it. So how can you install is guys mentioned. EKS CBS driver install. Yeah, you can see driver installation here. So this is going to be just a command. Okay, this one. So if you run this command, automatically the drivers will be installed in your Kubernetes. Okay. I'm running this. Okay, it is doing a lot of things. You don't need to understand. So the second thing, first, I'm going to mention the steps here. Create disk. Install drivers. Third one, create PV. Persistent volume is a representation of the storage. So now I'm going to search Kubernetes or EKS, EBS, PV. This is the dynamic provisioning example, but I'm just looking into static provisioning. This one. 03 EBS static. So if you think in a low level, like maybe you may worry. So I need to do a lot of steps. I need to create the disk. I need to install the drivers. Don't think in like that. So just understand in a general way. So as I said here, obviously you need to create the storage. Then drivers are mandatory. You need to install the drivers. So then I said, so this is the external object. Storage is external object. Kubernetes is not aware of that. So that is why this is a wrapper. So you need to represent this storage as PV. So I need to just create this PV. Persistent volume, I'm just giving it as EBS static. Okay. And this one is going to be your volume ID. What is my volume ID? Just go to your volumes and take this. Okay. Capacity. So we created 20 GB. And then, so this one, these are not required. We'll discuss that later. So very simple. I'm creating one PV object to represent the storage. So that is EBS static. And this is not XFS. Actually, this is outdated, but we still need to understand this. Stop using EBS as persistent on. As I said, this is outdated, but still, obviously, we need to understand this one. This is going to be ext4 actually. Okay, so I know this. This is going to be ext4 file system type. So very simple. So the AWS Black Store. So I'm just giving what is the volume and how much capacity. So that is what the representation of the thing. So now this PV is created. So in reality, what is happening here? So this EC2 is going to access EBS, right? So that is the whole thing we are doing. EC2 is going to access EBS. So EC2 is one service, EBS is another service. So now let us just check the role. So it has one role. Okay, just check this. It has one IAM role. So this IAM role, EC2 should have access to it. So now do you think the access is available here, EC2 to EBS? Can you just answer in the chat? So it is our responsibility to add the access. Make sure EC2 can access EBS. I'm just adding the permissions. EC2 full access if you give. Internally, it will have EBS as well. EC2 full is nothing but EBS as well. Just add this. Or let us just check EBS is available. Try the policy. Just add EC2 full access. Okay. So now I add it. So these instances will get access. Okay. Now push full cd k8 resources git full kubectl apply -f 03 EBS static kubectl get pv. Okay, so now you can see EBS static pv is created. Read write access. So these modes are nothing but Kubernetes pv access modes. So this is simple actually. Access modes are read write once. It means so it can only be read or written by only one pod. Okay, read only many. So the volume can be mounted to the many pods. Okay, many pods can read. Read write many is nothing but at a time many pods can read and write. Okay, so this is very simple. By understanding by seeing the name itself you can understand. Read write only one is allowed at a time. Read only many pods can read at a time. Many pods can read or write at a time. So this is the access mode. So I'm just giving read write once because why EBS read write once? At a time you can attach the hard disk to only one server. This is done. PV is done. Now we need to write PVC. Kubernetes PVC. Just let me write PVC example. This is PV and this is PVC. Persistent volume claim EBS static PVC I'm giving. So now we have the storage available. We have the storage available for Kubernetes. Now we need to use those storage. So to use those storage, you need to claim it. So while claiming, so you have to mention something here that is storage class. Storage class is not as part of static provisioning. So this is used as dynamic provisioning. Okay. So I just need to give storage class as empty. So this you will understand while discussing dynamic provisioning. Okay. So kubectl just get storage class. So we have some storage class available by default. Okay. So I'm just making it as empty. Okay. Because in static provisioning, you need to mention it as empty. That you will understand why it should be empty. So we have 20 GB hard disk available. So now maybe you want 3 GB or 5 GB or whatever it is. Okay. So I'm just asking for 3 GB, and then let us create our pod. Okay, let me create deployment itself. I'm creating deployment. So here you need to use this one, volume mounts. USR share Nginx HTML, and then this one. Now under containers, I am creating volume. So this volume, how I am getting this? Through the PVC, persistent volume claim, EBS static PVC. Okay. So this is the PVC, and this is volume. So you need to mount this volume to the container. Okay. So I just gave something as, I'm just giving the name as Nginx HTML. So the same name I have to give here. Okay, so these are the steps. Make sure it's easy to have access to EBS and create PVC way of claiming. Why should we have claim? Because the storage is available, but you need to ask for it. So that is the work of PVC. Create volume out of PVC and then mount to container. Okay, so that is what we are doing here. So do you think if you request 100 GB, do you think this PV will work? Please answer in the chat. The storage available is 20 GB. So if I ask 3 GB, it will work. But if you ask 30 GB, it will not work. Okay. Now let us try. Git pull. Apply. kubectl get pods. Saying container creating. I'm creating 10. So 10 will not work because read write only once. Read write once access mode Kubernetes PV access modes. Read write once. Okay. Now these three pods are running on one node. Just get me the guarantee. You can see you need to focus here. This is very good. The example I just created 10 pods. So we have 3 worker nodes. So I asked 10 pods. So 10 pods may be created in any of the node. So here by seeing this, I can understand 3 pods running. You can just see remaining are trying to be created, but they will not create because I gave read write once policy. So what read write once policy? Allow multiple pods to access the volume, but the pods should be running on the same node. So out of 10 pods, 3 pods went to one server. So that is this one. Okay. And the remaining 7 pods went to different server. Okay. So this server got access to EBS volume. So if a hard disk is attached to one server, do you think it can be accessed by different computer also? No. So that is what Kubernetes is saying. You can use read write once, but it will access by multiple pods, provided if the pods are in the same node. Now let me refresh our volumes. It was in creating stage earlier. Now let us see this. It is in use. In use, nothing but it is mounted to the server. Now let me delete this. kubectl delete -f03. So now this state is coming through. This state will come as available. You can see. So this is available. EBS static is available because I deleted. So the amount also is deleted. It means I disconnected the hard disk from the server. Okay, it's just taking some time in the background. Let's Control C, delete once again. Okay, it is deleted completely. Now I'm applying again. Just understand what is happening. I'm applying. So when I'm applying, a PV is getting created. Okay, for this volume. And I'm claiming I need 3 GB. And this one, once I claim, I'm attaching to the pod. So here I'm asking 10 replicas. 3 replicas are going to one server. So that server is accessing EBS like hard disk. So already it is attached. So the remaining pods is going to the different servers. Then they will not attach. Okay. Just for simplicity, I'm running this time one. kubectl get pods. Now you can see the volume state should be in use. I'm refreshing. The volume state is in use. So what happened in the background? So there is a Kubernetes cluster, and inside there is one worker node. So inside worker node, there is a pod. Okay. There is a EBS disk. So this is cluster. So this is node. After node server, everything is same. Okay. So this node, EBS is mounted to that node as hard disk, and then this pod is accessing this one. Okay. So now let me do one thing to demonstrate properly. kubectl exec -it bash cd usr share nginx html. So usr share nginx html. Now here I will create something. Echo hello world to hello.html. So where do you think this file is saved? So do you think this file is saved inside the server or in EBS? Just answer me in the chat. So file is stored in EBS or inside the server or inside the pod. Okay. So it is obviously inside the server. That is what I am mounting here at every stage. Now let me delete this pod. kubectl delete pod, and immediately another pod will come up. Now let us go and then check kubectl exec -it bash cd usr share nginx html. So here you can see still you have your hello.html, because the storage is not inside the pod, not inside the server. So that is inside the EBS. So this whole process, everything is manual because I created the disk as in a manual way. So that is why this is called as static provisioning. So dynamic provisioning, what will happen is there is something called storage class. Okay. So that will automatically create the disk and then automatically mount everything to your pod. So in that, you no need to give these steps. These steps will become automatic. But drivers you need to obviously install. Creating PV, creating disk will become automatic in dynamic provision. Okay, so this is EBS static provisioning. Static provisioning is always you have to create the disk, you have to create the PV, you have to create the PVC. everything you have to create, and then you have to mount to the pod. So then pod can access the storage. That is static. If it is dynamic, you no need to create the disk, you no need to create the PV, everything will be automatically created by storage class. So there are three objects: persistent volume claim, and storage class. Persistent volume is a physical representation of the actual storage. Persistent volume claim is requesting for the storage, and storage class is used for dynamic provisioning. You will understand in tomorrow's session. Okay, so this is the EBS. So there is something called EFS. EFS is elastic file storage. The condition of EBS is the disk should be next to your computer. Generally in cloud, it is in same availability zone, but EFS can be anywhere in the internet, just like our Google Drive and Microsoft Drive. So the drive is maybe somewhere in US, but we are still able to upload and download the files, that is through the networks. That is called EFS, Elastic File Storage. That is the implementation of NFS, Network File Storage. Network file sharing or storage. That is the EFS. So in tomorrow's session, we will discuss EFS static provisioning, and then we will start the dynamic provisioning. So the storage is very important part of Kubernetes. Mostly you will face interview questions from this. Okay. So any questions still here? No questions? Everything clear? But I am sure you have to practice it multiple times. Okay. At least the storage part. Yes, Sri Hari. Sri Hari, you have some question? So where we need this storage, where is it important? Can someone please respond in the chat? So we have user data, and then we have orders data, and we have cities and countries. We have payments data. Everything we are storing right now inside the Kubernetes servers directly. But users, orders, everything, these data like MySQL, RabbitMQ, and then what else we have? MongoDB and Redis. So these are our databases. So these databases should not be inside the servers. So these databases should be, the data should be stored inside EBS or EFS. So our RoboShop, we are going to extract the databases from Kubernetes. We will keep the data inside the storage, and we will run only app tier and web tier here. Okay. The actual data, the crucial data is going to be stored inside the disk so that it is always safe. Okay. So that's all for today's session. If no doubts, we can end the session. Yes, Srinu.
Yeah, hi Shiva, good morning.
Yeah, hi. Morning.
And regarding that FS type, why we are using only ext4, why not XFS?
That is the file system type. We actually no need to understand. There are multiple things. XFS, ext4.
Yes.
There are file system
Actually,
types.
ext4 is outdated, right?
I don't know actually.
Okay.
I am not the file system guys.
Yes.
ext4, ext3, there are a lot of things. ext2.
Okay.
So you mean ext4 is outdated, huh?
Yes,
Then
now
what
we
is
are
the
using all
latest?
XFS only we are using.
Okay. Maybe XFS also can work.
Okay.
Oh yeah, so different. Yeah, we try with XFS, that will also work.
Okay, thank you.
Yeah. Now here, what is the type we have? XFS. Yeah, that will work. Varun, other?
Yeah, sure. Here Fluent is for pulling the logs or
So sorry.
Fluent we were using Fluent, right?
Yeah, Fluent is shipping the logs, correct?
Because earlier Logstash, I mean, FileBit we used as a monitoring agent. It was
FileBit is to ship the logs of pod. Fluent is to ship the logs of server.
okay. And one more thing, so daemon set, I mean, if it is a manager Kubernetes, that's fine. So if it is on premises, daemon set pods, it will be run on master nodes also, is that right?
Master node, I doubt will not run.
Because under kube system namespace, kube flannel or network plugin calico flannel, so
If
it
you
was
guess
running a,
kubectl get nodes, if you get master also here, then it will run in master also.
because if we run kube, I mean on manager Kubernetes, master node managed by AWS.
Yeah,
So
correct.
here we will not get any master nodes. I think on premises we'll get master nodes
Yeah,
only.
on premise is very completely outdated. I
Mhm.
don't remember what happened, but
Okay.
how this will be run internally is while running d1 set, internally this command will run. If you are
Mhm.
getting here master node also,
Mhm.
then it will run.
Okay.
Okay, doesn't matter. We no need to worry too much about it. Either
Okay.
it will run in master or not. If it is available here, then it will run on that as well.
Okay.
Okay, so yeah, obviously master node logs are also important because if you are handling in on premise, master node is also our responsibility.
Correct. That's what I'm asking. I
Okay.
think, yeah.
Yeah, so
Yeah.
then daemon set will also run in master node and it will also ship the logs of master node.
Yeah. That is the reason I think in the spec tolerations was applied
Yeah.
so that it will be matched. Okay. Yeah.
Okay, so that's all for today's session. See you in tomorrow's session. We'll start EFS and dynamic provision. See you. Bye bye. Have a nice day.